In this video, I'm going to discuss with you about MCQs on point estimation, and I'll cover the MCQs based on definition, result, and it will also cover the characteristic of the good estimator along with the MLE. So before switching over to the MCQs, let's have a quick glance over all the important pointers which will help for the problem solving. X is a random variable which is with the PDF f of x theta, and here theta is known as parameter for the distribution, and in this topic it is always unknown and we want to predict it or we want to estimate it. So what is the first point we should remember? That any function of the random variable, let's say x1 xn be the random variable, and let's say the function is some function of let's say t of x1 x2 xn. We usually write in this symbols t or something else. Then this function is called statistic if it is used to estimate the unknown parameter theta of the distribution, and it is called estimator, right? A statistic is said to be estimator if it is used to estimate the unknown parameter theta, right? So some important point we have to remember that there are two kind of estimation. One is point and another one is interval, but in this topic we are going to only cover the point estimator based problem. So if we want to know what is a point estimate, it is a single value that estimate the parameter, or you can say a single value estimate of the parameter. For example, sample mean is a point estimate of a population mean because we get a one value for the that. And interval estimator give you a range of the values where the parameter is expected to lie, and usually the confidence interval is most common type of the estimate. Now let's look at some good characteristic, or you can say characteristic of a good estimator. Characteristic of good estimator, there are four characteristics. The number one is unbiasedness, second is consistency, and efficiency and sufficiency. We are going to discuss quickly one by one all of them because many questions can be constructed based on in this topic. So usually this topic is very theoretical and result based, so all the important point must be clear. So first, if somebody asks you that what do you mean by unbiasedness, so an estimator T is said to be unbiased estimator of a parameter theta if expected value of this estimator is equals to the parameter. So if E of T is coming out to be equal to the parameter, we can declare that estimator as the unbiased. So if it is not coming out to be the equal to, obviously either it will be greater or less. In that case, we can call them positively biased and negatively. If value is more than theta, we can declare it to be the positive biased, and negative when it is less than. Now when they are biased, obviously there will be a difference between its value or expected value. So the difference is always known as the amount of bias, right? Now because usually most of the questions are result based, formula based, so remember that sample mean is an unbiased estimator of an unknown population mean. Here I have taken the example for the second result is also important from the MCQ point of view. There are another parameter, let's say for the normal population it is variance. So if we say sample variance, it is always denoted by this expression, deviation of each sample from its average mean, and when we square it and divide by actual value of n, it is called a sample variance. It is always a biased estimator for the variance. Whereas this estimator, when we divide by n minus 1, this same expression we observe over above, but if it is divided by n minus 1, then it is always unbiased estimator for this unknown population variance. So sometimes this result is very good for MCQ point of view. The second property is a consistent estimator. Now in this case we are going to take up the larger value of data set, so the sample size must be larger. So here we can say that if there is an estimator, we can declare it to be the consistent if Tn converges to theta in probability as n tends to infinity. What does it mean, and how we can handle it, or the question? So there is a sufficient condition for the consistency, and this is very important for the problem solving. If we want to find out whether the given estimator is consistent or not, we can first find its expected value. If for larger value of n, when n tending towards infinity, if expected value will getting closer to the parameter theta, or second condition is its variance is becoming 0 as n tends to infinity. If these two conditions are fulfilled, we can declare that estimator to be the consistent estimator of theta. So this is enough for checking the consistency. Now there is a one in property that is called invariance property of consistent estimator. What does it mean? It is saying, let's say if we know that there is a consistent estimator, and here it is written Tn of, let's say, parameter theta, and if there is any continuous expression. Now if we find then how the function of that estimator, the continuous function based on that estimator is behaving, so that will also be always consistent estimator of the same function for the theta. So when question will come, we will look into that how it can be utilized. So I have included one question which can be based on this invariance property. Again, I have written that sample mean is always a consistent estimator of population mean. So for MCQ purpose, we can directly use it. It will give us a help for solving a question on a fast track. Now, before switching over to the efficiency, we want to point out that why it is required to check this characteristic. Usually what happens if there is an estimator which is unbiased as well as consistent, then how do we identify which one is the better? So in that case, we can check its efficiency. For example, there is a one very basic example that sample mean is always an unbiased and consistent estimator for the population mean. And similarly, sample median is also the unbiased and consistent estimator for the same parameter mu. So when we are getting two estimator, how do I identify that which one is the better one? For that, what criteria we can look into? That we will see their variance. So the variance discussion is discussed in terms of efficiency. So it is saying that, let's say if we have a two estimator which are consistent of any parameter theta, if variance of the T1 is smaller than variance of T2 for all n, then we can declare the estimator T1 to be the more efficient than T2 for all sample size. So just like in the previous slide, we discussed about the that sample mean and median. So here the formula for variance and formula for variance of mean and variance of median is available. So we can observe from these two formula that variance of median is more than variance of mean. So we can declare that sample mean is more efficient than the sample median. Now most efficient estimators, and we want to find out which is most efficient among all. So the one with the least variance will be declared as the most efficient estimator. Now if we want to check the efficiency of any estimator, for example, if we know that the one with the least variance is available, and let's say here we are calling T1 as the most efficient with the variance V1, and T2 is any other estimator with the variance V2, and we want to check its efficiency, and here efficiency I have denoted by E. Now if you want to find its efficiency, what we can do, we can see the ratio of the variance with the means the most efficient variance divided by any other. So obviously the numerator is smaller, denominator is larger, so the ratio will always be less than 1. So it can be checked, we can evaluate its efficiency. So questions are also based on it. Now the last characteristic is here sufficiency. Now how do we discuss the sufficiency? The sufficient estimator is declared as that estimator which contains all the enough information regarding the parameter, right? I have written two times regarding, just a minute. So the parameter that is called a sufficient estimator. Now there is a one very important result which is called a factorization theorem for the problem solving. And before switching over to this theorem, I would like to discuss with you the important point which is needed for it, and that is called a likelihood function or a joint density function. What does it mean? Let's say there are random sample taken from the population with PDF f of x theta. the likelihood function is always denoted by capital L, and it is a product of the PDF at every sample. What does it mean? Let me write down into, it's written in the notation form. This pi notation is always for the summation, not summation, product. So it means if I rewrite it, what does it mean? It means that I am saying first sample where at PDF value at the first sample into at the second sample and so on nth sample. So if you are taking the PDF at x1, x2, xn and take a product of it, it can be rewritten in the compact form in this manner, and this is nothing but it is now onward we'll call it a likelihood function or a joint density function. So the factorization theorem is important to identify or you can say to check whether it is a sufficient estimator or not. So any estimator, let's say T, is sufficient for theta if and only if its joint density function or you can say likelihood function is expressed as factors. So they gave you two factors in this slide. So what does it mean? GT theta means it depends only on theta and x through the value of t, and hx, which if you see any other term, that must be independent of theta. So if it can be broken into this model and we observe there is some formula based on sample, and that formula or you can say function we have just discussed in the first slide, that estimator is a function of the sample. So any expression which is containing a sample can be taken up as a estimator, or you can say sufficient estimator. Now the last point before switching over the MCQs is a very important pointer for this topic. It is called MLE, maximum likelihood estimator. So for that what we need to do is if we want to maximize or we want to see the what is a maximum likelihood estimator for the population parameter, what we need to do is, this is parameter theta, let's say, what we need to do is we will first find out its likelihood function, and then to find its maximum likelihood function estimator we need to differentiate it with respect to theta and put it equals to 0. It will provide us the answer for that, and it is maximum because second derivative is always less than 0. The alternative way is written, why? Because usually what happens, the likelihood function is very complicated expression, and sometimes finding its usual differentiation is very difficult when the lot of exponent entries are there, more terms are there, so it become very tedious task to do the differentiation. So what is an alternative? Because log is increasing function, so whatever maxima minima is attained by any function, the log will also follow the same trend. So what we can do, instead of finding derivative of L directly, we can first find out the log of L, and then we perform the same process of finding the maxima minima. So the derivative can be taken over here. So, and the same manner, the second derivative of the log L must be less than 0. So this will be the more preferable thing for the MLE. MLE is always consistent but need not be unbiased, because we know that it is based on the sufficient estimator, so we can apply the same thing for the sufficient. It is always consistent but need not be unbiased. This is last, we have written here one formula because there are some questions where in MLE they ask you the variance of the estimator, right? So how we can find out? We can apply this formula, 1 upon expectation of minus second derivative of log L with respect to theta square. Yes. I have taken first 10 to 12 questions directly based on definition. So my suggestion would be, if you, because we have just gone through all the important formulas and points, so I want that what you can do, the best way is to check your knowledge. You can pause the video when you see the slide, pause the video. I'll give some moment before discussing the answers, that you can keep your answers with you, and when it will be discussed by me, it will check whether you are clear with the concept or not. So let's begin with the first one. A function that is used to estimate parameter is called what? Estimator. So option D is the right answer. Now second question is talking about some expression. The statement number 1 is saying sample variance is an unbiased estimator of a population variance. That is not correct. Sample mean is more efficient estimator than sample median. It is correct. So we observe that statement 1 is wrong, statement 2 is right. So statement 1 is correct, statement 2 is incorrect, is in option number A. So the question number, sorry, I made a mistake. Statement number 2 is correct and 1 is incorrect. My mistake. So B part is the correct one. Now let's see the next question. Now again I will suggest you can pause the video, see the answer, keep your answer for 3, 4, 5, 6. They are directly a formula based, result based. Now let's begin the third one. This estimator is said to be unbiased estimator of the parameter theta if what? Obviously when expected value is equal to theta. I want you check 4th and 5th on your own. Give your answer or check it in the first 2 slides where I discussed. Now I'm going to switch to the 6th one. You tell me which is the positively biased, because answer of 4th and 5th is among A and B, A and B. One of them has option A, another has an option B. So identify and share your answer. The 6th equation is, if t is a consistent estimator of theta as n tends to infinity, then which of the following is true? Now in consistency we check 2 points. One is expectation value and another one is variance. And we know that expected value will tends to theta and variance will tends to 0. So we can find out this is only happening in option number B. So 6th question answer B is the right one. 7th, in sampling from normal population with mean mu and sigma square, they must be unknown. The sample mean is consistent estimator of what? Sample mean is consistent estimator of population mean, and which is option number C for the 7th question. Now here the 8th question is based on efficiency. They are saying if T1 is the most efficient estimator with the variance V1, T2 is any other estimator with variance V2, then the efficiency E of T2 is defined at what? Obviously the variance V is, E is always less than 1, and we know that V1 is less than V2. That means V1 by V2 must be less than 1. So it means V1 by V2 is always right now is in option number A. 10th question is saying that let's say there are a random sample from the population with unknown mean, mu and variance sigma square. Which of the following is an unbiased estimator of sigma square? So here we can see that because variance is unknown, so there is a doubt in option number B and option number D. But remember they have written the population of unknown mean. So when mean is unknown, and obviously we will based on the sample mean. So the right option is the option D, which is an unbiased estimator for sigma square. Now in example number 11, now we have to start doing some work. They are saying that this estimator is an unbiased estimator of what? So always remember whenever the mean and variance is given, so how we can write on? We can write on expectation of each xi is equals to mu and variance of each xi is equals to 1. So that is a one very common step. So what we are going to do is, for example, if we are finding mean of that, it means t is equals to nothing but x1 square, if I open it, x2 square up to xn square. So I want to find out what is expectation of t. Expectation of t is divided by n also. So expectation of this is equals to 1 by n come outside, so it is expectation of x, I am writing directly, expectation of x1 square plus expectation of x2 square, this is inside, expectation of last term is xn square. So how do I identify expectation? So remember this formula, that expectation of x square, because we know that variance is equals to expectation of x square minus expectation of x whole square. This is very important result for the topic of checking unbiasedness. So it means the variance value is ex square value is always equals to variance of x minus expectation of x whole square. So it means variance of each xi will also follow the same trend. So from here we can get the value that expectation of each square entry is equals to variance plus square of expectation. So variance is 1 and square of expectation is mu square. So we are getting here each number is equals to 1 plus mu square plus 1 plus mu square. So I think answer is very evident. When 1 plus mu square is n times 1 plus mu square divided by n. So we are observing that expectation of this estimator is coming out to be 1 plus mu square. So 1 plus mu square, or you can say mu square plus 1. So that become the right option. So this become a very important result. This is also similar, just like we did the previous one. They are saying t is unbiased. So let us write down how we can do that. T is unbiased means expectation of t is equals to theta. Then they are saying which of the following is correct. Obviously in option t square is the estimator, so I can say that E of t square is equals to what? Variance of t is equals to E of t square minus E of t whole square, right? So it means E of t square is equals to E of t whole square plus variance of t. And we know that E of t is theta, so it will be theta square plus variance of t. So what we are observing? We are observing V of t square is more than theta square. So it means we can say that E of t square. So we can say that E of t square is biased estimator for theta square, because variance of t is some positive quantity and it is always greater than, so we can say it is a bias. So option number C is the correct one for this question. Now question number 13 says that T1, T2 are two unbiased estimator of mu. So let us first write down what does it mean. It means E of T1 is equals to mu and E of T2 is also equals to mu. Then they are asking you T3 is what? So first of all let us simplify T3. E of T3 means, because expectation when we apply, so constant is same as that, so 0.33 will be common. Expectation of T1 plus, because in MCQ we have to skip some steps if it is not very important to note down. We know that E of A plus A of V1 T1 plus T2 is E of T1 plus E of T2. Coefficient will be remain same, and from here we can observe that this is nothing but 0.33 times mu, and this value we can use these values here, right? These values here we can say this is also mu and 0.67 is also mu. I think almost answer is clear. We are getting 1 times mu means mu. So we are observing expectation of t square is matching with mu, and it means this T3 is unbiased estimator of mu. So option C is the correct one. Yes, if we would have gotten some plus value, then we can write down the positive negative. So it is a unbiased estimator of mu. This is an invariant property, and it is saying if Tn is a consistent estimator of theta and phi of theta is a continuous function, then what? We have just seen in the beginning that then if we apply psi on both sides, the same function, psi of Tn is a consistent estimator of psi of theta. So psi of Tn is a consistent estimator of psi theta is only in option B. Okay. 15th question is, let T1 be the most efficient estimator with the variance, okay, so variance of T1 is given, and T2 be any other estimator with efficiency 0.4 then variance of T2. So we should know that the formula E is equals to, here the most efficient is written on the top and the other one is written on the bottom, and in this case they have given a 0.4 as an efficiency value. V1 is given as 0.25 sigma square and V2 is not known. So what we can do, we can write down V2 here 0.25 sigma square upon 0.4. So when we simplify, after simplification, what we can do, this will be 25 by 40, that means 5 by 8 sigma square, right? So we can get it equals to, this will be 0.625 sigma square. So we get the option A as the right answer. 16th question is saying that there is a random sample of size 5 of the distribution with mean mu and variance sigma square. Then variance of the estimator t. Always remember, student, that if somebody is saying expectation of ax plus minus by, it means it is equals to a times ex plus and minus. Plus will be remain as plus, minus will be remain as minus b of y. But if somebody is saying variance of a plus variance of x plus minus b of y, if we are going to get out of it, then a become a square. So variance of x, it is for the independent, okay. They are all independent. It is assumed that they are identically independent, so there is no product. So we will get plus minus become plus and b square variance of y. So we have to remember this result. All right. So what they are saying, then variance of this estimation. So it means variance of t means variance of t means 1 by 2 become 1 by 4 square, and then variance of x1 plus variance of x2 plus variance of x3, negative become positive variance of x4, this last negative become plus variance of x5. So when you are opening the variance for all of them, all the negative become plus, so it means they are all equals to what? Sigma square, sigma square, sigma square, sigma square, sigma square. When somebody say it is taken from the distributed mean and variance, it means they have given us E of each xi is equals to mu and b of each xi is equals to sigma square. So currently they are not asking us expected value, they are asking us a variance. So when we apply variance, I am getting here 5 times sigma square upon 4. So 5 times sigma square upon 4, when we simplify, we are getting 1.25 sigma square. So option C is the right answer for that. Okay, so we have done this much. Let's look into the next one. It is talking about 5 samples drawn from the normal population with unknown mean mu. If t is 2x1 plus x2 plus lambda times x3 by 4 is an unbiased estimator of mu, find lambda. It means it is given expectation of t is equals to mu, it is given. Now if I replace expectation of this 2x1 plus x2 plus lambda times x3 upon 4 is equals to mu. So obviously in expectation I told you it will be remain as the same constant. So 4 comes out and we will get 2 times e of x1 plus e of x2 plus lambda times e of x3, and this 1 by 4 will go on the other side, 4 times mu. And we know that if they are normal population with unknown mean, that means each exi is equals to mu. So if each ei is equals to mu, that means 2 times mu plus lambda times mu is equals to 4 mu. So we got mu can get cancelled. We're getting 3 plus lambda is equals to 4. That means lambda is equals to 4 minus 3. That means lambda is equals to 1. So in this, a number of questions can be created. Via this discussion, I just want to share the variety of the problem one can create out of this topic. So many more such questions can be constructed. So let's see now the question number 18. The question number 18 is talking about if x1, this is little calculative, so we have to pay attention. x1, xn be the random observation from the Bernoulli expression, which take value 1 with the probability p and 0 with probability 1 minus p, right? So then they are asking what is the, then this is what? An unbiased estimator of p square, biased estimator of p square, p. So we have to first identify whole structure. Since it is a Bernoulli process, the expectation of each xi is equals to p, right? And variance of each xi is equals to p1 minus p, because it's a Bernoulli. And when we want to find out, remember that here they have taken sum of xi. That means I am going to substitute t as a sum of xi, right? If t is sum of xi, then I am interested in what is expectation of t. That means I am interested in what is expectation of this xi. When you are having each xi expectation is p, so when I add, I'll get n times p. That means this is nothing but it is a binomial. It is a binomial estimator, right? So we are going to see it is equals to np. Now we want to find out similarly what is variance of t. Variance of t is equals to np1 minus p. Now these are two important points, we have to remember it, because now come to the point here. This function can be rewritten as, I have substituted summation as a t, so it is t upon n into n minus 1. So we want to find out that it is unbiased estimator of which expression. So that means I am going to solve this expression. The numerator is t into t minus 1 upon n into n minus 1. So when I simplify, n square minus n will come out, and expectation of t square minus expectation of t. So I can skip the step, because expectation sign negative positive remain same. Now we can apply the same logic. Expectation of t square, I'm not going to write property again and again, we have discussed in the previous. It is equals to variance of t plus e of t whole square. So it means we can substitute the value of numerator. This part first I'm going to write on e. This is vt, and vt I have used this, so this is vt and this is et, so I have to square it. So in place of vt, what we need to write down, np 1 minus p, and in place of this we have to write down minus, okay, plus we have to follow this next step. So I have not yet written this part. They have two terms. One term is this variance of t, the second term is n square p square, right? So we have done with this part, and minus et. What is et? It is np. So now we are going to open this expression in the numerator. It is, if I open, it is np minus np square plus n square p square minus np. So plus np minus np will get cancelled, and denominator is n square minus n. So I think we are almost near to the answer. N square minus n, p square is coming out, n square minus n. So this will get cancelled and we get p square. It means expectation of this formula is coming out to be p square. So it is a unbiased estimator of p square. So option A is the right one. It was little calculated. But anyways, we did so many questions with hardly less than a 1 minute, so some question can take some time. Now let's see the 19th question. This is something similar like the previous one, but let us have a quick glance. They are saying random observation from the Bernoulli. Variable x takes a value 1 with the probability p, 0 with the probability 1 minus p. Then the consistent estimator of the parameter p into 1 minus p is what? Here we have to use invariance property. Why? Because we should know that sample mean is a consistent estimator of population mean, and population mean is parameter means mu. Sorry, here it is p. So x bar is a consistent estimator of p. So because one time p, there is a one trial, single trial, because expected mean is np for the binomial, but for Bernoulli mean is equals to p. So it is my estimator, and this is my parameter, and this is my estimator. So by the result, sample mean is always consistent estimator of the population mean. So I can directly use it over here. Now by consistent property, invariance property, we can see that this function, which is equals to p minus p square, it's a polynomial. That means we can use the invariance property. If x is a consistent estimator of p, then x minus x square, x bar minus x square is a consistent estimator of p minus p square. So we have to find out which expression is matching with the other one, x bar. So it is only the B option which can be matching with it. So it's a polynomial. Polynomial is always continuous. So we can use the invariance property over here. So logic is, once you know that the basic ingredient of the estimator is consistent estimator for the parameter, if you see any polynomial structure, or you can say a continuous function structure, it can be a consistent estimator of the same parameter. So option B is the right one. Okay, the 20th question is saying let x1, x2, xn are the random sample from the exponential distribution with PDF 1 by theta e to the power minus x by theta, then its likelihood function. And we have discussed that likelihood function is what? L is equals to, we have to take a, I'm going to write it into the simplified form. E to the power we write on x1 by theta, and second 1 by theta e to the power minus x2 by theta. It means all the n function will be multiplied, and we know that when this is 1 to the power theta n, and here base is same, 1 by theta is common, so base is same, power can be added, so it means x1 plus x2 up to xn. And you know that replacement of x1 plus x2 is summation of xi, so option B is the only right option, right? So option B is the right answer. Next one, they are asking us that a random sample taken from the population with the PDF theta x theta minus 1, which of the following is sufficient estimator parameter for theta? So here I am going to use a factorization theorem. For that, the step number 1 is, let us write down the likelihood estimator, and we know that it is x1 theta minus 1, x2 theta minus 1, x n theta minus 1. So we are observing theta to the power n is multiplied, and here x1, x2, when we write down, they have the base with the same power. So it means when something is multiplied, this notation is pi of xi, I from 1 to n to the power theta minus 1. So we can observe that pi function must be the right answer. So here option A is the correct one, right? So we can see that one is the right option. It can be further simplified, but we got a clue, so that's why. Next, they are asking, this is just like the same question, which of the following is the sufficient estimator? So I'll take up you to the question number this one, 1 by theta. So we will take help of this expression. We observe that you can go to the question number 20 for the beginning part. If it is any confusion, I am writing directly. L is equals to 1 by to the power theta e to the power minus summation of xi upon theta. So we can very easily observe that by factorization theorem, this is a function of theta and summation of xi into 1. So here we are observing that the expression, which is only depending upon parameter and the function of sample. So function of sample is only this much. So we can identify this is a sufficient estimator by factorization theorem. So sum of xi. Sum of xi is the option number B. So we can identify the sufficient estimator. 22nd question is based on MLE. They gave us some sample, not some, there is some mistake. We should write down x1, x2 up to xn. Let they are the random sample of the Poisson distribution, unknown parameter lambda, given log L is, so okay, they have given some work is already done in the question. Log L, till log L question is given to us, simplified form. L is a likelihood estimator. for the lambda, which of the following is MLE of lambda? So the step number 1 is already done, log of L is already done. What we need to do is we have to differentiate d by d, because when there is a single parameter we can use the ordinary differentiation and put it equals to 0. Now I am going to write down what is the derivative of minus n lambda is minus n. What is the derivative of log lambda? Log lambda is 1 by lambda, and summation of xi will be as it is. There is no lambda, so answer is equals to 0 and this is equals to 0. So from here we can identify n is equals to summation of xi upon lambda. So lambda is equals to summation of xi upon n, and it means this is the estimator. Summation of xi upon n means x bar. Since they have not given x bar, summation of xi upon n means option number B is the right answer for that. That becomes the, even if we differentiate it once again, it will be always negative till xn. Okay, the same question, but they have asked one more step. I have shared with you formula. They are asking us a variance of estimator. So let us have a one glance over the MLE part. Just a minute. Yes, this formula is used, excuse me. What I need to do is I'm going to find out the second derivative. First derivative we have already done in the previous step. We can check it. This is coming out to be minus n plus summation of xi upon lambda. You can see from here we have already done this part. So here one time more differentiation is what? D2 log of L upon d lambda 2. That will be 0 plus, not plus, 1 upon lambda derivative is minus 1 upon lambda square with summation xi. Now what we need to do is we need to find out the formula 1 upon expectation of minus, this is a variance of the lambda, double derivative with respect to the parameter of log of L, and we observed it is e to the power minus summation of minus become plus, minus summation of xi upon lambda square. Now lambda square will be go out of the, so lambda square become in the numerator e of summation of xi. Now e of summation of xi means what? We know that x bar is equals to summation of xi upon n. So what we can do, we can replace it by lambda square expectation of n times x bar. So you know that here expectation of x bar is matching with what? Because sample mean is always an unbiased estimator of the population. So x bar is an equals to lambda for this question, because here we have taken up the Poisson distribution to distribution. The parameter is changing because mean for the Poisson distribution is lambda. So it means E of x bar is equals to lambda. So we can replace it by doing lambda square in the numerator, n will come out, and expectation of x bar I can use here is equals to lambda. So 1 lambda will get cancelled, lambda upon n. So answer is lambda upon n, which is option B as a correct answer. Okay, so 24th question is the maximum likelihood estimator of the parameter alpha of the population with PDF of the sample of unit size. So n is equals to 1 here. So it means when we find out the likelihood function, we will get only the same function. This is equals to 1 upon alpha square. There is a mistake in the question. There must be 2. Okay. So we have to write on here. There is an error in the problem. So 2 upon alpha square. So this is L is equal to 2 by alpha square, alpha minus x. So when this is a L unit size, so we don't have to multiply, it's only single term. So what is our step? We have to take log of L first. Log of L is log of 2, log of A plus log of B minus log of c denominator, and you know this 2 can come in the front, so we can rewrite it is equals to as a 2 times log of alpha, right? Now we will do derivative of with respect to what is a parameter. Alpha is a parameter, so with respect to alpha, log L will be differentiated and put it equals to 0. So log 2, it is not containing alpha, so 0. It is containing alpha, so alpha is a coefficient 1, so derivative is alpha minus x. This side is again alpha and it is minus 2 times, so I'm going to write on minus 2 will be there, and log derivative is 1 by alpha is equals to 0. Now when we simplify it, obviously when we simplify it, 2 by alpha is equals to 1 upon alpha minus x. 2 alpha minus 2x is equals to alpha. That means this is x. So 2 alpha minus alpha is equals to 2x. It means alpha is equals to 2x. So it means alpha hat is the always notation for the MLE is equals to 2x. So option B is coming out to be the right answer. So we have covered so much, so many questions. I want this in this last slide. 25th and 36th, do it yourself, try yourself, because they are similar kind of question. I've told you that minus 2 and 3, be careful. They are asking you the variance, so you can apply the variance formula and simplify it. Variance of each x1, x2, x3 is sigma square. Now apply the formula and identify which is the right option. This is also the same question. Here E of each xi is equals to mu, and V of each xi is equals to not sigma square. They have given you 4. So you have to apply the same technique up to your t is given as xi plus same. So you have to identify how to find out this answer. Be careful, t is given as x1 square plus x2 square up to xn square. So this is not xn, 5. So you have to use the same process what we did in the beginning with the mu square and 1. So you apply the same steps and identify the answer. I hope you got some idea how to deal with the different category of question of this topic. So thank you for watching.